You are listening to The Vocal Technologist. Spoken tech for your ears.
Right now, 10 meters below the surface of the ocean off the coast of China, there's this massive data center that is just silently churning through algorithms.
Yeah, and it's literally using the freezing seawater to keep its servers from melting down, which is wild.
It's crazy. And meanwhile, hundreds of miles above our heads, Google is renting server space on a SpaceX satellite.
Right.
And this thing has a wingspan wider than a Boeing 747, and it's packed with like 100,000 NVIDIA chips.
It really just shatters the old mental model we all used to have, you know? For years, artificial intelligence was just, well, it was a text box on a screen.
Right, exactly. A brain locked in a digital jar.
Yeah, completely dormant until you typed a prompt to wake it up.
But looking through this stack of sources we have for you today, and it is a really dense pile of tech dispatches from June 2026, that digital jar has basically been smashed open.
It really has.
Our mission on this deep dive is to map out this astonishing leap. I mean, we are looking at AI that is growing hands, taking physical form, operating orbital infrastructure, and autonomously rewriting the underlying fabric of the internet.
We are tracking a fundamental paradigm shift here. We've moved from artificial intelligence as like a simple tool you wield, to artificial intelligence as the invisible infrastructure that actually runs the world.
And the best place to see that invisible infrastructure taking shape is at the software layer, right? We are officially deep into the agentic era.
Oh, absolutely.
OpenAI has crossed 1 billion monthly active users, and they are just aggressively shedding the chat part from ChatGPT to become this super app that actually acts on your behalf.
But the thing is, for an AI agent to actually do work, and, you know, to book a flight or manage a database, the architecture of the internet has to be completely rewired.
Because the internet you use every day was built for human eyes and human fingers.
Exactly. Think about the friction of simply logging into a website. You encounter a sign-up form, a two-factor authentication prompt, maybe a CAPTCHA asking you to, like, click on traffic lights.
Right. It's the absolute worst.
Yeah, an AI agent gets completely blocked by those human-centric barriers. And this has forced developers to invent entirely new protocols just for machines. WorkOS, for example, just released a new open protocol called auth.mfd.
So I'm imagining a sort of digital bouncer for bots.
That is a remarkably accurate way to picture it, yeah.
Instead of filling out a form, the agent just like flashes a badge.
Pretty much. It's a machine-readable markdown file placed at the root directory of a service.
Right.
So when an AI agent arrives, it doesn't look for a login button. It just reads that single text file, dynamically learns the specific authentication rules for that server, and then executes a seamless handshake.
Wow. So we're basically building a shadow internet parallel to our own.
We are.
And it goes way beyond just logging in. One of our sources details this tool called KTX that acts as an, quote, executable context layer for massive data warehouses.
Right, so it doesn't just point the AI to a spreadsheet.
Exactly. It actually translates the complex business logic of a company so the agent understands what the data actually means before it starts moving it around.
Which is absolutely necessary when you have agents writing and deploying code. I mean, we are even seeing the emergence of a Stack Overflow for agents.
Wait, really?
Yeah, and unlike the human version of Stack Overflow, which, you know, relies on people upvoting good answers, this uses a really brutal multi-agent verification loop.
So they are essentially peer reviewing each other.
Constantly. Because static training data gets outdated the literal second a new software framework is released. So these agents generate canonical knowledge by constantly reality testing their own code against live production environments.
If it crashes, they learn.
Exactly. Pioneer's new inference API operates on the exact same philosophy. Instead of running generic pre-trained models, it learns continuously from live traffic failures, basically retraining its neural pathways on the fly.
And a massive new report from Cursor actually confirms this is completely reshaping how high-performing teams automate their software development. But here is the massive roadblock hidden in that report. If agents are so incredibly capable at writing code, why haven't human software engineers been rendered obsolete?
Because writing syntax was never the actual bottleneck in software development.
Right. The bottleneck is figuring out what to build in the first place. AI agents are kind of like brilliant, highly caffeinated interns.
That's a great way to put it.
They can write a script perfectly, but they are completely oblivious to the unwritten rules of the company. And in the engineering world, they call this intent debt.
Yeah, intent debt is the silent killer of autonomous systems. It's the accumulation of all the office politics, the whiteboard scribbles, the vague emails.
Stuff that never gets written down.
Exactly. The historical constraints that explain why a system was built a certain way.
So when you hand the keys over to an AI model that doesn't understand the historical context of a decision, the cost of not explicitly writing down your human intent becomes, like, financially catastrophic.
Oh, yeah. The agent optimizes the code and accidentally breaks a critical legacy system because nobody bothered to document why it was there in the first place. What's fascinating here is that this vulnerability explains the massive scramble we are seeing for durable execution tools.
Right.
Moving an AI agent from a slick 5-minute tech demo to a real-world production environment is an absolute nightmare. If a complex task takes 3 hours, the agent is almost guaranteed to lose its train of thought, drop its state, and just crash.
So developers are building guardrails, like the Pidgeotto repository, which uses Postgres databases to act as an ironclad memory bank.
Yeah, it allows agents to manage retries and actually preserve their state if they fail.
Instead of just dumping raw data into a prompt and hoping the AI figures it out, companies are building these vertical agents that rely on a highly structured hierarchy of context.
Because the messy reality of the back end dictates that humans still hold the ultimate accountability for what actually gets delivered.
But the chaos of the back end stands in stark contrast to what is happening on the consumer front line. While developers fight to keep agents from crashing, Apple has been executing this massive stealth pivot to hide all that complexity from you.
The timeline of this pivot is really fascinating, actually. Early in 2025, top Apple executives held a secret meeting without CEO Tim Cook.
Wow, really?
Yeah, they were looking at the raw, brute force reasoning power of models from OpenAI and Anthropic, and they realized Apple was facing a legitimate existential threat.
So they formulated a survival plan, took it to Cook, and recommended handing the keys to Siri over to Mike Rockwell.
Right, and Rockwell is the visionary who led the Vision Pro headset development. Putting him in charge of Siri signals a fundamental shift toward spatial, highly contextual computing.
Because Apple understands that an AI agent needs to know exactly what is happening on your screen and in your physical environment to actually be useful.
Exactly.
Which all culminates at WWDC 2026. This is widely viewed as Tim Cook's legacy-defining moment as he prepares to transition to executive chairman, passing the CEO baton to John Turnus.
Right.
But I look at the landscape, and Apple still seems light years behind the raw capabilities of their competitors. How do they plan to win the consumer AI race without the smartest model?
Well, by understanding that the average consumer lives very far from the bleeding edge of AI research, most people have zero desire to tweak prompt parameters or manage context windows.
Very true.
Apple is executing an iPhone core AI strategy. They aren't trying to outspend Google on server farms. They are turning the iPhone itself into the central node of a new agentic ecosystem.
So they win by default because they own the device in your pocket.
And they prioritize safety and privacy over raw power. The true victory in consumer AI won't go to the smartest isolated model. It will go to the most seamless integrated ecosystem.
We are definitely seeing this demand for secure, isolated environments everywhere. Apple just released a native container tool for incredibly lightweight virtual Linux environments on Mac.
Yeah, and even open source package managers like Homebrew just released version 6.0.0 with strict new security mechanisms to verify the trust of different software taps.
So while Apple builds a walled garden of localized AI, the open web outside that garden is fundamentally mutating. Google Chrome is now testing an AI mode default.
Right.
It bypasses traditional search entirely, synthesizing answers instead of giving you links, and they are permanently killing the workarounds for ad blockers like uBlock Origin.
The traditional document-based web is definitely fracturing, but developers are actually rebelling against the homogenization of AI design by pushing for what they call a weirdly human web.
The HTML and Canvas experiments are the perfect example of this. For decades, websites have been built using the document object model, which forces everything into rigid, invisible boxes.
Yeah, grids everywhere.
But a Canvas element, on the other hand, is basically a blank digital painting. Developers are now using an experimental Chrome feature to render ordinary HTML directly inside these rich canvas environments.
It allows them to completely break free from the grid. Buttons can warp, text can fluidly shift.
We are seeing innovations like data type variable fonts. As you type a sentence, the font dynamically morphs the text into literal interactive data charts.
It's wildly creative. Yet at the exact same time, we have analysts looking at government websites and pointing out that the most accessible, indestructible sites on the internet completely ignore all of this.
Yeah, they're still built on raw, simple, 1990s style HTML.
That highlights a profound tension in user experience right now. As AI interfaces become exponentially more complex and proactive, human tolerance for digital noise is just plummeting.
People are literally setting their multi-thousand-dollar iPhones to grayscale mode just to strip the dopamine triggers from their screen time. But Apple can afford to focus entirely on calming the user interface because the underlying AI models powering all this tech are turning into a commoditized bloodbath. The giants are basically tearing each other apart in the model wars.
The competition has definitely reached a fever pitch. Anthropic recently released Claude Fable 5, which is classified as a Mythos-class model. It is largely outperforming every public model available, boasting a staggering 1 million token context window.
And to put that into perspective, for anyone not deep in the tech weeds, a token is roughly a piece of a word. A 1 million token window means you could hand this AI a dozen thick novels, and it can hold every single character, plotline, and detail in its working memory simultaneously without forgetting page one.
And Anthropic pairs that immense memory with incredibly strict built-in behavioral guardrails. But, the organizational structure behind that power is just as compelling as the tech itself.
Oh, yeah. Dario Amodei, the CEO of Anthropic, operates the company with exactly one direct report, his chief of staff.
That is practically unheard of for a company of that valuation.
It really is. He completely insulates his time to focus purely on big-picture research direction, while his sister, President Daniela Amodei, manages the sprawling day-to-day operations.
That singular focus is yielding pretty brutal results for their competitors. Anthropic's dominance has effectively neutralized the value proposition of AWS Bedrock.
Right.
Bedrock was pitched as this neutral platform where developers could access a buffet of different AI models. But because developers only want the absolute best reasoning engine available, Bedrock has essentially been reduced to a first-party wrapper for Anthropic's Claude.
This market consolidation has OpenAI backed into a severe corner. They're facing immense margin pressures from billions in compute costs. Anticipating a vicious price war, OpenAI is reportedly considering drastic price cuts on their models, willing to just bleed cash to starve Anthropic of market share.
And while those tech titans incinerate capital to win the foundational layer, the trickle-down effect is completely rewriting daily workplace productivity.
The specific tools emerging from this fallout are wild. There is a platform called OA Creator that uses AI to instantly synthesize and manage influencer marketing campaigns, entirely eliminating the massive manual spreadsheets agencies used to rely on.
Oh, wow.
Yeah. Then you have tools like Granola, which listens to your virtual meetings in the background and automatically enriches your raw notes with contextual data and action items. We have basically crossed into a workplace culture where literally everything is recorded and analyzed.
We are also seeing the widespread adoption of tools like WispFlow, which allows users to dictate text 4 times faster than they can physically type, with the AI auto-formatting and correcting the tone in real time.
Even software engineers are using large language models to write their personal tech blogs. Though many of our sources complain that the AI violently strips away their unique voice, leaving just a sea of perfectly grammatical, incredibly boring content.
Yeah, that's the trade-off.
But the sheer speed of these tools forces a difficult conversation. If an agent automates your spreadsheets and you can dictate emails 4 times faster, do you just work less? One source advocated for the philosophy of doing nothing at work.
The premise being that in the modern knowledge economy, performance is dictated by rare outlier opportunities. So instead of grinding at maximum capacity all day, you intentionally reserve your mental energy to hunt for high-leverage decisions.
It sounds ideal. You let the AI do the busy work while you wait to make the big strategic play.
It is an idealist view, yeah, that unfortunately collides with what economists call the Jevons misunderstanding.
Okay, unpack that for us.
Well, traditionally, the Jevons paradox states that when a technology makes a resource more efficient, say, more efficient coal engine, it actually increases the overall demand for coal because it becomes cheaper to use. The industry scales up.
So, applied to AI, if coding becomes wildly efficient, the demand for software explodes, and we need more human programmers to manage it all.
That is how it usually works. But the misunderstanding with autonomous AI is that this market expansion might entirely bypass the human labor bundle.
Oh.
The AI doesn't just make the programmer faster. It eventually replaces the need for the human entirely in that specific workflow. The pie grows massively, but you might find yourself employed at progressively lower wages, handling the leftover tasks that are too annoying to automate, completely missing the financial benefits of the industry's expansion.
That is a bleak economic forecast.
It forces a total reimagining of human value, really. Look at how Terence Tao, one of the greatest living mathematicians, approaches this. He realized AI isn't going to replace a master mathematician by solving a massive theorem in one shot.
Right.
Instead, AI is best utilized when a human takes a monumental problem and breaks it down into thousands of tiny, manageable subproblems for the AI to process.
So the human role shifts from execution to orchestration. We become the foreman of a digital assembly line, managing the flow of thought rather than doing the heavy lifting.
Precisely. But that assembly line is no longer contained to a server rack. We have mapped out the software protocols, the mutating web interfaces, and the shifting economics. Now, the AI is demanding a physical body to interact with the real world.
And the sheer ambition of these physical projects is staggering.
Mm.
Jeff Bezos has launched a startup called Prometheus. His goal is to build an artificial general engineer.
Right.
He wants to inject these powerful reasoning models into physical robotics to revolutionize the design and manufacturing of hardware, everything from automobiles to spacecraft.
It is an incredibly bold bet, primarily because robotics currently exists as what scientists call a pre-paradigm field.
Meaning the industry hasn't even agreed on the fundamental rules of physics and movement yet.
Exactly. When a roboticist builds a tool today, they are encoding their own implicit and potentially deeply flawed theories about what embodied intelligence actually is.
Right. Do you train a robot by having it mimic human motion, or do you let it learn from scratch via reinforcement learning?
Yeah, and if the industry commits to the wrong paradigm, progress on a general-purpose robot will hit a brick wall.
Which makes a counter-movement like the familiar so compelling. It's a robot created by the original inventor of the Roomba. But he didn't build a humanoid butler to fold your laundry. He built a soft, furry robot about the size of a dog.
Oh, right.
Uses AI purely to interpret your emotional state and form intimate bonds.
It is designed entirely around the psychological concept of presence rather than attention.
That is the key distinction. Every piece of tech we own fights for our attention. The familiar has no screen, no engagement feed, no dopamine looping notifications, and by default, it doesn't even connect to the cloud.
Wow.
It just exists in the room with you. It is a physical, offline, emotional companion. The anti-smartphone.
While we are building furry robots to comfort us, we are simultaneously making massive strides in physically merging human biology with this technology.
Yes, the timeline on brain-computer interfaces is accelerating faster than anyone predicted. China just officially approved the world's first commercial brain implant, the NEO.
Really?
Yeah. It sits directly on the brain membrane, decoding neural signals so patients can control prosthetics with their thoughts, entirely outpacing Neuralink's commercial rollout.
And the biological interventions go down to the genetic level. A company called Life Biosciences is currently testing a gene therapy designed to reverse age-related vision loss.
The mechanism they are using to control this therapy sounds like science fiction. The genetic switch is engineered to be triggered by a common antibiotic.
That's incredible.
You take a pill, the antibiotic molecule binds to the engineered receptor in your cells, the switch flips, and the gene therapy activates to literally regenerate the tissue.
If we connect this to the bigger picture, think about the progression we just traced. For years, AI was a brain in a jar. Now Bezos is trying to build its hands, Colin Angle is giving it a furry body, and biotech firms are hardwiring these systems directly into our organic brains and genetic code.
All of this physical manifestation leads to an inescapable bottleneck, though. Power.
Oh, massively. Embodied AI and autonomous agents are incredibly thirsty. The terrestrial power grid simply cannot support the scale of compute required.
This is why General Motors is frantically developing next-generation sodium-ion batteries that bypass the need for lithium and require zero active cooling.
It is also why we are seeing massive breakthroughs in nuclear energy. A startup called Antares just successfully achieved criticality in a small modular nuclear reactor.
And what makes Antares revolutionary isn't just the size, it's the safety mechanism. Instead of relying on complex active cooling pumps that can fail and cause a meltdown, they engineered the safety directly into the physics of the fuel itself.
Wow.
They encapsulate the uranium in advanced ceramic layers that literally cannot melt at the maximum temperatures the reactor can physically reach.
The fuel itself is the failsafe. But even next-generation nuclear and advanced batteries on Earth are not enough. The sheer scale of compute required to run a global agentic economy is pushing infrastructure right off the planet.
We are putting data centers in the ocean and in orbit. In China, they just fired up the world's first wind-powered underwater data center.
I remember reading about that.
They submerged the massive server racks 10 meters deep, utilizing the freezing ocean water for natural free cooling. But the truly mind-bending infrastructure pivot is happening in space, driven by the SpaceX IPO.
The financial scale of that IPO is unprecedented.
SpaceX raised $75 billion, and the offering was 4 times oversubscribed. This is the financial event that could officially make Elon Musk the world's first trillionaire.
But the capital raised is less important than what they're building with it. Google just signed a deal to pay SpaceX $920 million a month to rent Orbital data center capacity.
SpaceX is constructing the AI-1 satellite. It carries an interchangeable compute payload, and Google is launching 110,000 NVIDIA chips into orbit.
Think about the advantages of a space-based data center. You have access to raw, unfiltered solar power, and you completely bypass the zoning laws and grid constraints of terrestrial power network.
It is a phenomenal engineering feat, especially when contrasted with the crumbling state of our legacy space infrastructure.
Oh, for sure.
NASA's Deep Space Network barely survived the data load of the Artemis II mission. And the upcoming Artemis III mission requires astronauts to execute a deeply complex transfer between NASA, Blue Origin, and SpaceX crafts while in orbit.
Yeah, one source described it as a terrifying Rube Goldberg machine of corporate failure points.
Back on the ground, the race for physical autonomy is already separating the winners from the losers. Waymo's autonomous driving tech has matured to the point where they are launching a $29.99 premium subscription tier for preferred rides.
Meanwhile, Tesla's highly publicized robotaxi fleet is completely stalled out at just 59 vehicles.
When you look at all of this together, trillion-dollar space compute economies, AI agents writing code, and autonomous infrastructure completely routing around human labor, it becomes obvious that the economic physics of the world are fundamentally changing.
Which explains the massive political shockwaves detailed in our final sources. We are seeing politicians grapple with a reality where human labor is no longer the primary engine of economic growth.
Donald Trump has been publicly musing about holding summits with top AI executives. The proposal on the table isn't about regulation. It's an economic proposal where the American public receives a direct wealth share or a literal equity stake in these AI companies.
Right.
It is a proposed mechanism to offset the massive job displacement that an agentic economy will cause.
Setting aside the politics of who is proposing it, the fact that a national wealth dividend is being discussed at the presidential level proves the severity of the shift. As intelligence becomes infinitely cheap to mass produce, economic value will aggressively slide to the few places that AI models cannot reach.
Which brings us to the ultimate question for you, the listener. With data centers floating in orbit, AI agents learning the unwritten rules of our workflows, and massive models threatening white-collar labor, where do you fit into this future?
You have to look at the timeline. Self-sustaining AI meaning systems that can source their own power, repair their own servers, and exist entirely without human intervention are likely more than a decade away.
Okay, so we have time.
Yes. For the foreseeable future, human accountability is paramount. Our ability to orchestrate complex thought, to manage intent debt, and our capacity for genuine physical connection remain our ultimate competitive advantages.
You don't have to outcompute the machine. You have to outhuman it. We've covered a staggering amount of ground on this deep dive.
We really have.
We've watched software agents learn to navigate the internet through markdown files. We've seen Apple stealthily build a local AI ecosystem while the open web mutates into fluid canvas art. We've looked at furry robots that provide presence without the burden of attention, and orbital servers running NVIDIA chips under the cold vacuum of space.
It is a profound reshaping of our reality. And looking at the sheer scale of this infrastructure, it leaves me with one final, lingering thought.
Let's hear it.
If our software agents become totally autonomous economic actors, if our data centers move out of our cities and into international waters and outer space, and if the wealth generated by AI becomes a distributed national public dividend, does the very definition of a country fundamentally change? Does a nation stop being a geographic location with physical borders and instead become a distributed orbital computing network?
That is a wild, paradigm-breaking thought to chew on. Next time you pick up your phone or open your laptop, take a close look at the software and the hardware you're interacting with. Because the autonomous future we just mapped out, it isn't science fiction. It is already running silently in the background. Thanks for joining us on this deep dive. We'll see you next time.
Spoken Tech for your ears.